Hi, everybody. We are Kai, and we're going to take the next 30 minutes or so discussing our exciting solution to the problem that the ISE department here at RIT is currently facing. So that being said, what is the problem? Recently, the department has seen its enrollment numbers plummet over this past several years. Why? Well, there are several reasons for that, one of which being a lack of awareness among high school students. A lot of kids aren't even aware of industrial engineering as an option. Secondly, if they are aware, they often don't understand exactly what it entails or what they could do with a degree of that nature. And finally, there has been little to no community outreach done by RIT in putting themselves out there to local high school students to raise that awareness or understanding. So that's where we come in. We've been tasked with creating an engaging way for high school juniors and seniors to address those issues, to become aware of IE, to become interested in IE as a potential career path. So who are we as Kai? I'm Brett Kajanik. I am the financial analyst for the team, and I'll go ahead and let the team introduce themselves.
My name is Matt Dickman, and I'm the projects manager for the team.
My name is Zach Kutu. I'm the design engineer.
I'm Megan Britt. I am the community liaison.
I am Ketan Thakur. I'm the customer liaison.
Awesome. So let's get into it. Here's our agenda that we'll be discussing in the presentation. We're just going to take you through our process and coming up with our solution step by step, starting with the scope and objective. So the ultimate goal of this project was to learn about and implement various project management tools to create a solution to the problem while also addressing the stakeholder needs and requirements. In so doing, we were tasked with developing an interactive game that the department can use as the outreach tool, as mentioned previously. So here's a brief overview of the final product that we created. The actual design gameplay and specifications will be discussed in more detail coming up, but basically you see the image of the 3D printed object. We also included the necessary tools and hardware that the students will need. And finally, we included facilitator notes. Again, this will be explained in further detail, but basically it includes instructions on how to play, answers to questions the student may have, and explanations of the industrial engineering concepts that will be represented. So I mentioned earlier that one of the objectives was to meet the stakeholder requirements. So what are they? Firstly, one of the requirements is that it should be completed within 40 minutes, as this is designed for high school students to be able to complete in a classroom setting within a classroom period. Secondly, as mentioned, it's supposed to increase the understanding of the IE concepts. That's the whole purpose of the project. Secondly, the game should be able to be played in a group. The group was consistent of 4 to 8 students. In addition, it should meet all the safety and regulatory standards. Obviously, it has to be safe for the students to play. And finally, as mentioned with the facilitator notes, should be able to be facilitated by someone with any level of industrial engineering knowledge, whether it's a high school teacher, camp counselor, etc. They do not need IE experience to be able to effectively facilitate the game.
So in order to meet the requirements, the stakeholder and the technical requirements, we designed a 2-stage assembly game. And what this does is it requires team collaboration. The game is hands-on. You will not be able to complete it successfully if you don't. So the first assembly period is essentially a free-for-all, where all of the tools, the hardware, and the object components are placed randomly in a box that is at a separate table from where the players will be assembling the object. And there's a few rules to kind of make their lives a little more difficult. They can only grab one object, one student out, or one player at a time can only grab one object, tool, or piece of hardware from the box and walk it back to the assembly station. So the goal here really was to make it difficult and inconvenient pretty much in any way possible. And hopefully the players will not be able to assemble this object during this first period. So then once the first period is over, moves on to a discussion period where the students first, they just kind of discuss what was difficult. Like they could mention that they had to only grab one piece at a time. That was very inconvenient. The fact that everything was mixed up, that was very inconvenient. So basically, we want them to recognize all of those inconveniences during that first period. And this is also where we introduce the relevant IE concepts that could help them successfully assemble the object during the second assembly period, or if they were able to successfully assemble it during the first period, improve their time and be able to assemble it quicker and easier. So some of the things we could suggest would be removing unneeded tools, pre-orientating the parts. Maybe if they want to split up the tasks amongst team members, someone can build the top half of the object, someone can build the bottom half, however they want to work that. So then we move into the second assembly period. And in that, essentially, they should have everything that they need to successfully build this. They're given a standard work document that includes different BOMs for the hardware, for the tools, step-by-step instructions with images on how to put this object together, what screws go where, what tools are for what screws, different types of exploded views. So they're also given some time before that period to just lay out their station how they want and really implement those IE tasks. And then it moves on to a second discussion period just to reiterate the effectiveness of those IE principles, in that it created a more successful and easier assembly process. So talking first about the object itself, it is 3D printed out of a material called PLA. And this is a relatively low cost material. It's not very structural, but we didn't need that for this. It's good enough for the beating that this object would take. And essentially the object is 17 parts. 8 of those are body parts, and 9 of those are hardware. And the hardware is split up into different size screws, screws that require different tools. So we have a flathead screwdriver or a flathead screw, Phillips head screw, Allen socket head screw, things like that. And we wanted to design it so that it was able to fit on a regular high school size school desk. So if that's all they had available for their assembly station, then it would be able to be built on those. So then we moved on to the game box. And this is just your standard corrugated cardboard box. You can see in the image there, we have our logo for Kai on 4 sides. And it's sized correctly and optimally to fit all of the different components for the game. So now what is in that box? Firstly, you have the facilitator notes, 1 copy of those, obviously for the facilitator. And then you have the sets of tools. Again, not all the tools are required, but they all need to be given in that first assembly period. And those are the Allen wrenches, the regular wrenches, and the screwdrivers. And then you have all of the required hardware. Those are all in a bag, a labeled bag, so are the tools. And those are all your different sizes and different head types. And then you have the bag also labeled of the actual assembly object components, and then the 8 standard work documents that are required. Since our game is for 4 to 8 people, we included all 8. So if you did have a team of 8, everyone would get the necessary standard work documents.
A big part of our project is being able to test the prototype, because this is going to be our main way of like quantifying our success and being able to say that this is what we wanted our project to do. And then through testing, we can say that our project has lived up to that so far. So we created 4 test plans to encompass all of our stakeholder and system requirements and just check to make sure that they're hitting the targets that we want them to. So our first test plan was regarding the facilitator notes. And this was really just to ensure that they contained all the necessary information and that they were easy to understand and easy to follow so that the facilitator could make the gameplay as fun as possible and just easily give that to them and make sure they could follow along. The second testing plan we had was for full gameplay. So this is when our students went into a classroom and actually tested the game from start to finish, just to make sure that it could be completed in a classroom setting and that everything went as we had planned. The third testing plan was about IE material. So we wanted to make sure that all of the industrial engineering concepts were accounted for and that people could physically pick them out and write them down and say that, yes, this was seen and it was taught throughout the activity. And lastly, we had a testing plan for measurements. So this included things like how many parts the final assembly included and the dimensions of it, anything that we could really just physically count and ensure that it was meeting the requirements. So for validation of our stakeholder requirements, we thought that a post-game survey would be the best way to kind of quantify some things that were harder to measure, such as how fun the game was, or some things like industrial engineering concepts learned. So on the right side of the screen, you can see a little sample of some of the questions on our post-game survey. And hopefully the users would fill this out accurately and give us a good idea of how we were doing. So we just want to be able to collect all of this data through testing and make any necessary changes. So we ended up testing a group of 5 students in the classroom, and these were some of the results that we obtained from this. So the big thing we were trying to measure through testing was the critical success factors. So we looked at a fun factor, the students' interest in IE after playing the game, and how well they learned the concepts throughout the activity. So all of our CSFs, we felt met what we were looking for, and we felt that we could improve, seeing this was the first test, that things would get better. So once we made these improvements, we could move forward. Some of the feedback that we received from the group was that there was a poor flow in the facilitator notes. There were difficult discussion questions, so the questions were just a little out of a high schooler's league. They probably wouldn't be able to answer these questions, and that kind of defeats the purpose. Another was that there was unclear directions in some cases, so it kind of made it difficult for the facilitator to really complete the activity like we had wanted them to. And lastly, there was some confusion surrounding the standard work document and some things we would need to clear up there. So we had some corrective actions that were put in place based on the feedback and data we collected from testing. Our first corrective action was about adding a bill of materials to the standard work document. So the purpose of this was just to ensure that people knew where certain pieces of hardware would go in the assembly and make sure that there was no confusion on how to actually assemble it, because the purpose of the second iteration or second run through of the assembly was to really correct what was wrong in the first one. So we cleared that up a little bit. We also reduced the difficulty of the discussion questions just to make sure that students would be able to answer it and that the facilitator wouldn't sit there while nobody could answer. We also made the IE concepts, we moved it to an earlier section in the facilitator notes so that the facilitator would actually introduce these concepts before the second assembly, and students would be able to learn the concepts, apply it to the second assembly, and then be able to answer the discussion questions that we posed to them afterwards. We also decided to include an industrial engineering knowledge question into the survey. So we didn't have a good way of saying that we met this target. So we kind of wanted to quantify that question. The last two bullet points are about the facilitator notes. So the first one is that we just added a quick start guide. This just makes sure that the facilitator can easily go through the quick start guide and say, okay, this is what I need to do, kind of clear up any confusion that he or she may have. And lastly, put in a tear down section to the facilitator notes, just so that the facilitator would be aware that this was going to be part of it, and you just need to make sure that that could be completed. We also had some corrective actions that just came about as the project progressed. So we didn't, as it progressed. So from the planning phase, there were some things where we would need to make changes. We couldn't plan everything perfectly from the start. So as things happened, we could put in these corrective actions to make the necessary improvements. Our first one was just that we updated the model dimension requirement. This was just changing it from 24 by 24 by 6 to 24 inches cubed. It doesn't make much of a difference in the end of our project. It still is able to be administered in a classroom setting, and it just helped us. Secondly, we removed one of the standards surrounding 3D printing just because it wasn't necessary. It didn't really pertain to our project, so we were able to remove it and only use the safety standards. The third corrective action we put, this is one of the bigger ones that we had, was we needed to rework our original CAD model to allow for screw to expand inserts to be installed. So originally we planned to just drill and tap the holes on our assembly, but the structural integrity of the plastic just wasn't good enough. So we needed to come up with a solution, and our solution ended up being these inserts, which you can easily set into the holes, and then we could put in the necessary screws we needed. There was one issue that came about from these inserts. 8 out of 9 were successfully installed, but 1 had some issues. So we put in a corrective action just to rework that and make sure that it worked perfectly. And lastly, we needed to increase the depth and diameter of the countersink within our 3D model so that the insert could be inserted in and then sit there flush without sticking out a little bit, because there's a small lip on that insert.
Speaking of the overall timeline of the project, on the right hand side, there's a Gantt chart which reflects the timeline of our entire project, starting from the project charter until the customer handoff. So total of out of 14 tasks, we complete 13 tasks on time, which is 92.85%. There were a couple of early finished tasks which we were able to complete. The first one was CAD model of assembly object. The second one was purchase object hardware and tools, and third one was the production plan. So all these 3 tasks were pretty much completed before time, which gave us time for completing the task that was not like for the late finished tasks. There was only one task which was not completed on time, which is a 3D printing of assembly object, which was mentioned earlier by Matt, where we had to put in corrective actions for the rework of the 3D printing of assembly object. Now, talking of the budget, on the right hand side is a graph which shows the actual cost and the budgeted cost. So until week 4, we did not spend anything. So total budgeted cost for our project was $120, and what we ended up paying was $58.75. The cost breakdown was we spent $19.73 on the tools, $39.02 on the hardware, and we did not have to spend anything for the 3D printing since we were able to get it printed through the RIT construct. It was very interesting, and the last point was we were able to print the facilitator notes and SOP from the RIT printing labs. Now, for the risks. So we have total of 16 risks out of 6 were major risks. We were able to mitigate almost 93.75% of the risks. There was only one risk that was unmitigated, which was due to the increase in COVID-19 level, which prevented us from testing the prototype. So the lessons learned from this was we would require a more comprehensive mitigation plan in future, so that if any situation this pandemic arises, we are able to have contingencies in place so that we can mitigate these risks.
So now moving on to how we actually plan to produce this as a product rather than just a prototype. We included two pretty major parts to this production plan, one of which not listed here is the STL files that are required to 3D print the assembly object. And then the other is a comprehensive purchasing BOM that just shows everything that would be needed to produce a production grade game, and possible vendors that you could buy them from, the quantity needed for one game. So for example, on the picture to the right there, you can see that you would need 4 1-inch long hex drive screws. And from McMaster, who we recommend purchasing them through, sells them in packs of 50. We also included the lead time required on each part and the cost, and a link to exactly where they are on the vendor's website, if there was a website provided. We also gave the part number too. So for production, we assumed a quantity of about 25. This made it pretty difficult to get some of the quotes for things like the box, which I'll talk about in more detail in the next slide. But the 3D printing things were typically a quantity of 1. But when it came to the boxes, a lot of vendors, for especially the shrink wrapping, really needed order quantities up in the thousands to make it worthwhile for working with us. So we definitely ran into some resistance there. As far as all of the hardware required, so that's all of the screws and the screw to expand inserts. Those we recommend being purchased through McMaster-Carr. They have very short lead times, their prices are reasonable, and their package quantities are sufficient for the 25 production quantity assumed. So as far as the tools go, we recommend purchasing those through Harbor Freight. Now that's pretty much, at least for how low of a production quantity we have, that's as close to wholesale cost as you can get. Their prices are very, very reasonable. And a lot of wholesalers would not work with us because of the low production quantity. So we included the links and everything needed in that purchasing BOM from Harbor Freight. For the bags, those can be purchased from Ziploc. That's where we recommend, just because then it's very easy to identify the bag size and part number things that you need. But you could buy those from a regular grocery store or any like CVS or things like that. And then when it comes to printing, we use the RIT printers. You could outsource it through Staples, but since this is an RIT sponsored game, we felt that RIT could use their own printers to print the facilitator notes and the 8 SOPs required for each production game. So moving on to some of those quotes that I mentioned in the previous slide, when it came to the box quotes, like I said, we had a little bit of difficulty getting a lot of quotes for that, because a lot of companies really liked high volume orders, especially when it came to the shrink wrapping. But we were able to get 2 very solid quotes for an order quantity of 25. Uprinting and Pacola are the two, and you can see on the right-hand side there a screenshot of the top of the Uprinting quote. They're a little bit more expensive than Pacola, but they definitely, I'd say, give us more of the warm and fuzzies talking to them as far as being a more professional company and more well-rounded. But for lead times and things like that, and size and printing the label on the boxes, all of that is stated in the quote. Taxes included, shipping and handling is included, and things like that. So for 3D printing, you can see the Protolab quote on the bottom right there. And this one was pretty surprising. It was a lot higher quoted value than I think any of us expected. They were up at $1,115 for what's called a nylon 12 material, which is slightly higher quality than the PLA that we were printing at RIT, but not to justify that price. And then Xometry is another place we were able to get a quote from, same material, nylon 12, and their quote was about $440. So definitely way more reasonable than Protolabs. But the third option and the best option, and the option that we use for the prototype, is printing it through RIT Construct. It was free to us, but typically they charge per material, and PLA is a very reasonably cost material, so it would cost about $12 per one unit. The Protolabs cost and the Xometry cost are both for one unit too, and you might be thinking, wow, that's $25,000 to, if you went with Protolabs, to print the 25 needed for the games, but that is still cheaper than if we went because of our low production quantity, that's still cheaper than if we went the route of injection molding, because molds for those can run up to $30,000. So it just, it doesn't, because of the low production quantity, it doesn't make sense to go the injection molded route. So those are the prices for one unit. The only stipulation with the RIT printing is that you do need a valid RIT ID, but again, since this is an RIT sponsored project, we would assume that they could print using their own printers.
So the team just gave a huge overview of what we've been working on the last few months, and I'm going to take a few minutes to kind of explain how we've been working as a team together. So post our testing round, we had a survey sent out to each member of the team to kind of gather what their feelings were about the project. This asked several questions about how they felt about the project, how they felt about each other team member, and so on. There's a few things I do want to highlight from the results of this survey. First being, two questions were very similar, but they were very different at the same time. So team project satisfaction and project results. So the difference between these two survey questions was the team's project satisfaction was asking the individual how they felt about the product that we were creating as a team. Did they feel like it was what we wanted? Is it what we expected? Whereas project results was asking the individual, from what we have made, how close does it align with the engineering and the client requirements that we have put in place to meet our deliverables? Another thing I do want to highlight on this page is, though we had really good results for every category, our lowest scoring category was accepting others' opinions. So this question was targeting members to kind of to express how they felt about when they provided like a suggestion or a concern, they wanted to raise a concern throughout the project. Did they feel that their opinions were accepted or listened to or heard during discussion? And overall, it still turned out well, but I do believe that this is room for improvement for everyone on the team. It is a helpful tool that you can carry on into life after college, which takes me to the next slide about our team's learnings. So overall, there were quite a few things that we can take away from this semester. Some of these are courseworks that have been repeated throughout the semester through textbook readings, lectures from the professor, and deliverables made throughout the semester. But there are a few I want to bring attention to as they have larger repercussions and benefits to us as students as we are graduating or heading to grad school and all that. So on top of just writing charters and scorecards and status reports, with the pandemic going on, we have all have this new skill of Zoom under our belts. This is something that we probably would not have had experience with until we went to a new job that maybe required telecommunications between long distance employees type of thing. So I think that it's a great quality for us to have in our belt, resume builders and all that. On top of that though, it does require some risk managing. We've heard it 1,000 times, I'm sure, on campus, wear a mask, wash your hands, keep 6 feet. So that is considered risk mitigation because those protocols have been put in place to, keep numbers down. And this applies inside the classroom and outside the classroom as well. We will carry this on after graduation and such. 2 more things I want to bring up is outsourcing and project closure. So outsourcing, as Zach was saying in the previous slides, we were able to outsource outside of our group, but still internally with RAT, which ultimately provided us a very helpful financial gain. If we had to outsource outside of RAT, as you saw, it would have been very much over budget, and that would not be good. We probably wouldn't be able to even have a working prototype if that was necessary. But because we were able to utilize RAT's construct, we were able to get a prototype up and working. On top of that, project closure, I think, is something I want to highlight. I know as students, we can be very guilty about doing an assignment, turning it in, and never thinking about it again. But that is not accurate for what the real world will look like when we're in full-time employment. When you finish a job, you do need to think about what went wrong, what went well, so that when you cycle through and do your next project, that you're not making the same mistakes over and over again, especially if it is a pattern or a project that happens, every spring of every year type of project. And I know we haven't done our retrospective yet, but it is coming up in the next few weeks. And throughout this course, we have had to do check-ins with like status report and doing surveys and getting understanding of how the team is feeling and doing. And I think that kind of enhances the understanding of what needs to get done and what needs to be understood to be a great project team. So overall, we do believe that when we are comparing our critical success factors, that we have a very quality assured project. First, we believe that we have met all stakeholder requirements that needed to be met. On top of that, our schedule was on time despite the one hiccup we had with the prototype, but that was still manageable to get fixed by the end of the term. On top of that, as Zach had mentioned and several other members have mentioned, we were far under budget, which is very exciting that we were able to complete this with such success and under budget. Typically, if you finish it on time, sometimes you go over budget. But overall, we do believe that our project, through testing and through surveys, we have found that it does engage the players and it's increasing the IE knowledge as they play our game. And we do believe that this will be a very beneficial tool to the IE department to increase student enrollment rates. So thank you for your time. Are there any questions at this time?
Awesome.
Sweet.
Awesome.